The third part of a lab report is called data and observations. Since science is evidence-based, data and observations are the evidences of your experiment. Therefore, the data and observation section of your lab report is very, very important. They support your findings, whether it's a conclusion or a claim. So when you write the data and observations part of your report, you must think about that very carefully. First, what data need to be recorded and presented in your report? To answer this question, imagine you are a defendant in a courtroom. What do you need to provide to prove to the jury that you are innocent? Obviously, you have to present accurate and complete evidences. At the same time, your evidence must be concise. You cannot present everything you get from the experiment in your report. At the same time, you must provide enough evidence to prove what you claim. The second question you have to ask when you write the data and observations part of your report is, what format should be used to present the data? Depending on the experiment, the data can be very different. Most experimental data are individual numbers. Some of the data are computer-generated graphs, or we call them plots. Some data are photos, for example, photos of the PLC plate, gel, etc. Choose appropriate format to present your data. It is the decision of the person who is writing the lab report. So it is up to you. But the rule of thumb is the format you choose must serve your purpose. That is the rule of thumb. The most common formats to present the data are tables, graphs, images or photos, sketches or illustrations. The top part is a table. The bottom part is a graph or plot. When you present your data in a table format, make sure you have to label each column. Then, when people read your table, they know what these numbers are. Another thing I want to point out is, if you look at my table, I use different colors to indicate the data are different. If you see a yellow color, the data are from the experiment directly. If you see a blue box, the numbers are from literature. If there's no shade or the background is white, that indicates the numbers are calculated. If you present your data in a plot format, make sure you need to have a title for the plot. You also need to have titles for the x-axis and the y-axis. If the plot is linear, you need to show the linear regression line with the equation and the R-square value. The R-square value tells people how linear this line is. If it is perfectly linear, the R-square value is equal to 1. The closer the R-square value to 1, the more linear it is. But not all the graphs are linear graphs. If it is not a linear graph, you should not show the equation of a linear regression line. You should not show the R-square value because you don't expect a linear line. An equation with R-square value of a linear regression line does not mean anything for nonlinear lines. Therefore, you should not include that. Let me emphasize. You present the linear regression line equation and the R-square value only for linear lines, not for nonlinear lines. Well, another thing I want to emphasize is that when you present your data, make sure it will occupy the entire graph. You do not want all your data appear in a corner, because if all the data are in a corner, it will be difficult for the readers to see it. The numbers of your x-axis and y-axis should be big enough to read. It should also reflect the significant figures of your measurements. Another common format to present your data is to use sketches or illustrations. In your sketches or illustrations, you must label the connections very clearly. For example, for this particular experiment, each beaker belongs to different students. Therefore, you must label each beaker with the students' names. Also, the connections of the electrodes to the power supply and the current probes are also very important information. Therefore, from your illustration, the reader must be very easily to figure out how each electrode is connected to the power supply and to the current probes. But let me emphasize, the sketch does not need to be pretty, but it must clearly label the connections. Sometimes students may wonder, Dr. H, can I take a photo of the experimental setup to replace the sketch? My answer is no. Because even if a well-taken photo does not illustrate the connections and the beakers as clear as in a poorly drawn sketch. Therefore, as long as you label the connections very clearly in your sketch, it's better than a well-taken photo. Images and photos are more common for a biologist to present the data. It's rare for a chemist to present the images or photos as the data. But sometimes chemists do use photos or images as the experimental data. For example, if you use thin layer chromatography, TLC plate, to separate a mixture, the TLC plate is your experimental data. Then you can take a photo of the TLC plate, attach the photo as your experimental data. When you present your photo of the TLC plate, make sure you label the information very clearly, such as the starting line, the end line, etc.